Welcome to aminacademy.com. In fluid mechanics, regarding Raleigh's method of dimensional analysis, let us do some solving problem. Look at this example. The resisting force R of a supersonic plane during flight can be considered as a dependent upon the length of aircraft L, velocity V, air viscosity mu, air density rho, and bulk modulus of air K. Express the functional relationship between this variable and the resisting force. Here, the resisting force R is dependent on or depends upon the following, that is density rho, velocity v, viscosity mu, density, length L, length of aircraft L, and bulk modulus of water, air K. Now we can write the functional relationship. Suppose R, resistance R is function A of L power A, velocity V power B, mu power C, rho power D, and K power E. There are 5 dependent variables, where A is a non-dimensional constant, where A is non-dimensional constant. Now, substituting the dimensions on both sides. The resistance is a force R equal to M, force is mass into acceleration, M L e power minus 2, A times L, length is L is capital L here, and velocity is L t power minus 1 power B mu. Here viscosity is M L power minus 1 t power minus 1 power C, and rho density is M L power minus 3 power D, and E is then bulk modulus K is M L power minus 1 T power minus 2 power E. Now we'll comparing the respective powers. Here first power M, power of M in both sides, 1 equal, here M power 1, M is power is C plus D, then here M power E. It's equation 1. Then power of next is power of L here L power here 1 equal power of L is here A plus power of L is A, L is B, then L is minus C, and L is minus 3D, and L is minus E. That is for L is A plus B minus C minus 3D and C. Then power of T. Power of T here is minus 2. Here T is minus B. And here T is minus C. And T is minus E. There are 5 unknowns but only 3 variables. Expressing these 3 unknowns in terms of 2 unknowns. Here there are 5 variables and there are 5 unknowns. There are 3 variables. There are 3 variables and 5 unknowns. So it cannot be solved directly. Therefore, expressing 3 unknowns, therefore, 3 variables, that is 3 unknowns. Not unknowns, it is equations. There are 3 variables and 5 equations. A big mistake. There are 5 unknowns. But there are 5 unknowns but 3 variables. So there are 5 unknowns, 3 equations. We cannot solve directly because number of equations is not enough, because it is lesser than number of unknowns. So we have to express expressing 3 unknowns. Expressing 3 unknowns in terms of 2 unknowns. In terms of other 2 unknowns. Like mu and That means we have to express other unknowns in terms of mu and k. Therefore, express A, B and D. Therefore, express A, B, D in terms of C and D. In terms of C and D. Look at here. D is first. We are having equation from, we can get it from D equal 1 D equal 1 minus C minus C. Therefore, first D equal 1 minus C minus E and B equal B equal to here B equal 2 minus C minus E. 2 minus E 2 minus E minus 2E and A equal 1 minus B plus C. A equal and A equal 1 minus B plus C plus 2E plus C. That means other, we have this relation, then C minus C plus 3 minus 3C minus 3E minus 3 minus 3C minus 3E minus 3E plus E, all from these two things, and which is equal to minus C. Before that, we can express clearly. Look at here. Here, A equal 1 minus B plus C plus 3D plus E, which is equal 1 minus, under E we have B. Substitute this B, that is 2 minus C minus 2E plus instead of B is that is C plus 3 into 1 minus C minus E plus E. Then, which is equal to, by simplifying, that is all That means here from this opening this one 1 minus 2 plus c minus plus 2e because minus multiplication, then plus c into 3 into 1 minus 3c. Let us opening that one first. 1 minus 2 plus c minus into minus 2e is plus 2e plus c here. Then 3 into 1 is 3. 3 into minus c is minus 3c minus 3e plus e, which is equal 1. So minus 2 plus 3 is 1. Therefore, we get 2. Because here 1, here 1 plus 3 is 4, 4 minus 2 is 2. Then C is 1, 2, 2 C's and minus 3C, which is equal minus C. What about E? 2E, 2E plus E is 3E, 3E minus 3 is 0. Therefore, we have A equal 2 minus C. So we got D, B and A. So therefore resistance R equal A, constant A, L power A is what? 2 minus C, and V is 2 minus C minus 2E, 2 minus C minus 2E, because we are from here we are substituting, note it. LA this, V is this one, B and C and D and E we have to substitute here. So V and mu power C rho 1 minus C minus E and K E. So we are collecting the same base, that is R equal to A times L is here L square V square and rho power 1. Then with the power C's, look at here, power C have L minus C, V power minus C, V power C and rho power C. So we have mu over rho VL, because look at here, this having all power C's here. See, we are collecting power C's here. Then E power have, this is having E minus 2E and this rho is minus E, K is minus E. Therefore, K is positive E and rho V square over E. Therefore, we got this lengthy relation, in that we simplifying R equal rho A times rho A times rho L square V square, the functional relation phi We are introducing functional relation phi mu over rho VL into K rho V square. In that we are removing C and E power because of we are introducing a functional relation, new relation phi. Regarding this power C and E, that functional relation depends on that. That means by experimental we find the value of phi. So this is a functional relation of dragging force of flight aircraft when flying. We have done. Please subscribe our YouTube channel.